We're just applying the exponent rules in a different context. Same as the exponent rules. That's literally it. So you don't really need your calculator right now. So right now your laptop should be closed. Let's roll. Okay. Here's what it says, our 3 steps here. If you see division, you expand that first, then multiplication, then bring down the exponents. I'm just going to start doing it, and I think you're going to catch on very quickly. So same as the exponent rules. Multiplication, you add. Division, subtract. Power to power, multiply, or bring it out in front. It says expand the expression. So when we say expand, we're saying like you take the expression and you like stretch it out and expand it. Makes it, there's more, okay? It makes it longer. All right, so we'll do one piece at a time. You don't need to do this all at once. The first thing I see is division. We're going to expand that first. You see at the top of the page, when you have division, you can split it by subtracting. So natural log of 5x to the 7th minus natural log of y. So it's the exact same rules as exponents. When I see division, I subtract my exponents. Okay, right here, do you see how the 5 is right next to x to the 7th? You multiply. Or that's multiplication, that's what I should say. That's multiplication, so I can expand it with, look at the top, addition, right? Adding. And so I'm going to split these apart, I'll do natural log of 5 plus a natural log of x to the 7th. And then you still have this guy's at the end. Oh, whoops. Okay. The last thing and the last rule that we're going to talk about is when you see an exponent, such as this 7, this is the fun one. It gets to fly out in front and it gets multiplied to the log out in front. And so the last step here would be to rewrite it one more time. Natural log of 5 plus, I'm not going to write this every time, in different colors, 7 natural log of x minus natural log of y. Ta-da! So what you're trying to do is you need to make sure that each of the logarithms is just log of a single thing. You shouldn't have anything else side by side. Look at our next one. You see 3 is right next to x to the 4. So that's multiplication, which you can expand out with the plus sign. Okay, so log base 6 of 3. When you write this, they both have to have that base 6. And then it would be log base 6 of x to the 4th. The reason why I skipped straight ahead to the multiplication is because there was no division. And then you see an exponent of 4, so it's going to go out in the front. And so then it just becomes this. So that one would become 4 log base 6 of x. And then this one is still log base 6 of 3. And there's a plus sign in between. Try and color code. Now you're done. So again, I'll highlight this. This is called expanding. You are taking the single logarithm and stretching it out. Okay, we're going to do number 3 together, and then I'll have you try number 4. Number 3 is a little weird. You see the x is right next to the square root of y. So that's multiplication. So let's go ahead and split that apart with plus sign, and then we'll deal with what the heck to do with the square root of y in just a second. So it's log x, and then log square root of y, which, by the way, this doesn't have a base, but it does. It's just invisible. What is it? 10. Yeah, this is a common log base 10. All right, square root. I feel like we've been talking about this for a long time. I can rewrite that as an exponent. What exponent is it? 1/2. Thank you for not saying 2. Okay, yeah, the exponent is 1/2, and so it looks like this. I should have written smaller. Regrets. All right, well, we'll do our best. So you can rewrite that as 1/2, and really, I probably should have done it here. I might just have to erase that and write it. If you have an extra room, you could maybe just write it on the next line down. I'm going to erase so I can actually fit it. Sorry. And so this would become 1/2 log y, because that 1/2 goes out in the front. All right. Can you please try the next one? I see division, and so you should deal with that first. Split that apart first, and then you will split apart the 12 and the x. Okay, talk at your table, go. So obviously, in the denominator, you have 12 and x, right? Which you can split with an addition sign. But because they're both in the denominator, you would have to do it in parentheses like this. Does that make sense? Or here's the way you'll actually see it probably more commonly is like this, log base 2 of 5. Because they're both in the denominator, you end up actually subtracting both. So I subtract the 12, and then you could think of it like you're distributing that negative, okay? Subtract log base 2 of x as well. So anytime you see subtraction, it just means, hey, that stuff's in the denominator. And since in this case you have two things in the denominator, you subtract both, or your other option is to put it in parentheses, which you usually don't do. We'd usually do what I have boxed. You know. Oh, no. Oh, it was there and then it went away. Oh my gosh, sorry. Okay, take two. Condense as a single log. First, bop your exponent back. So who's the exponent here? Do you see it? You see the 3? So the 3 is going to go back as an exponent on the 2. So it's going to be log 9 plus log of 2 to the third minus log 3. These are all log base 10. Okay, baby bits at a time here. Let's go left to right. Always, unless you have parentheses, that's the way to do it. So left to right. We're just going to work in pairs. So first thing I see is I see a plus sign between these first two. So that means that they're going to be multiplied. Okay, for the sake of not having to write this out a million times, what is 2 to the third? 2 to the third, you can check your perfect chart or check, yeah, it's 8. 2 times 2 times 2. So that's equal to 8. So when I go to put these back together, you're going to see me write 8 instead of 2 to the third, okay? So log of, it's 9 times 8, which obviously is 72, but I'll get to that in a second. Okay, minus log 3. Okay, you see subtraction, so that means you're going to condense it back with division. So it becomes log of, this time I'm going to actually write it as 72. So that would be 72 divided by 3. Really wishing I had smaller handwriting today. Okay, whatever 72 divided by 3 is. $24. So log 24. Ta-da! If you have numbers, you can't just like put them all next to each other. I want you to actually simplify it and give me log. What is it? What are we taking the log of? Okay, you can do number 6. Go. Okay, you should have log of x divided by 9. You could put that in parentheses if you want. You don't have to. I'd take it. Okay. Let's start the next one together. So we have natural logs, but still the same rules apply. You have an exponent here on the 3. So that's going to bop back. Let me see if I can write smaller this time. So it'd be natural log of 3 raised to the third power minus natural log of 12. Okay, I would work left to right, but maybe figure out real quick, what is 3 to the third? 27. Okay, so that's what you're going to see me use in a second, okay? That's 27. So when we put these back together, we're doing 4 times 27. Okay, can you go ahead and try that one? I'll do it on the screen, but I bet you can do it. So when you have division, or when you have subtraction, you're going to divide them, put them back together. So you'd have natural log of, do you have 108 divided by 12? Which turns out to be 9. So your final answer here should be natural log of 9. Because I did 4 times 27 is 108, and then because I see subtraction, I divide. Number 8 would be log base 3 of x plus log base 3 of y to the third minus log base 3 of z to the 4th minus log base 3 of 2. Is that what you have? Oh, whoops, I did that too weird. 2. Big 2. Okay, you work left to right in pairs. Here's what we've got. You've got on the left side, you have a plus sign. So what do you do with those? Multiply. You don't need to put a multiplication sign between them. In math, when you have multiplication, you put things side by side. So it would look like this. Log base 3 of x, y to the 3rd. That shows me multiplication because they're all side by side. Technically, there's a dot here. You don't need the dot. Okay, and then you have some division. Minus log base 3 of z to the 4th. You're also subtracting log base 3 of 2. Okay, here's what this tells you. These are both being divided, so that means that they're both being subtracted, so it means they're both being divided, which means they're both in the denominator. Anything that has a subtraction sign is in the denominator. So what you're about to see is I'm going to go ahead and do these both at the same time. Both the 2 and the z to the 4th have to go in the denominator, so it looks like this, log base 3. In the top, you're going to have your x, y to the 3rd. In the bottom, you will have 2z to the 4th. I put the 2 in front because normally that's what we do. We would put coefficients first. That one's a little bit more complicated. Again, anytime you see a subtraction sign, it means that's division, put it in the bottom. About this, here's why. If you try and write number 9, like you did on that delta math the other day, we're like, oh, is that equal to x? And then I write it as an exponential like this. 3 to the x power is equal to 8. Can you do that? 3 to some power is 8? No. I mean, you can technically. It's a decimal. And so it's not going to be very nice. And so it's not one you can like do in your head. You can't even do it with a perfect chart. This is where your calculator comes in handy. And so we do what's called the change of base formula. Instead of trying to do that, because that's not going to work, you do log 8 in your calculator divided by log 3. And then it's going to do some magic for you and give you the answer. Pro tip for you, anything that has a bigger font is what goes in the numerator. So you can see the 8 has a bigger font. The subscript goes in the bottom. Okay, type it in, actually. Log 8 divided by log 3. And I don't know what it is, so I'll steal it from somebody when you have it. Some of us have calculators that can actually do the base button, which is great. But if you don't, which is most of us, then that's when we do this. And use Brenner's 1.224. Is that what we have? I have an older scientific calculator. Here's what I have. Or I should say this is what Braden has. 8, 9, I'm going to round it, 3. It says to 3 decimal places. So if you didn't get that, make sure that you've closed the parentheses. If your log button automatically goes it makes parentheses, you've got to close them after each number. Try that again. Okay, this next one is log 14 divided by log 8. Type it in, and then you shove it. Okay, if you did not get these decimals and you have no idea why, then can you raise your hand right now and I will help you? We're doing the common log on this one, by the way, which is why you're using this button on your calculator, LOG. Common log is log base 10. Okay, your next one has you do the exact same process, except it says do it, but use natural logarithms. Okay, this is like a classic EOC question because people forget you can do change of base formula with the natural log. That is the ln, so log base e. So I'm going to do this exact same thing, except I'm going to use a natural log. So natural log of 9 divided by the natural log of 26. You good? This one would be the natural log of 14 divided by the natural log of 8. So type those in your calculator real quick. Oh, you can't even see it. And get your decimals. Agreed? Okay, what do you notice about numbers 10 and 12? Do you see how they're the same? Amazing. So that's just to show you it doesn't matter what log you use. You can use the common log, which is log base 10, or log base e. As long as you use the same log on the top and bottom of the fraction, you're going to get your answer. Again, let me know if you're not getting that on your calculator. The last thing we have is to show you how you can use the properties to expand things even when it doesn't look like you can. You can do whatever you want as long as you use the properties correctly. So it's asking you in these last two problems to rewrite in terms of log 7 and log 3. These are both log base 10, but we're just going to rewrite them. So let's see. You guys are smart. 21. How can you do 21 in terms of 7 and 3? You can multiply. So you can rewrite this as 7 times 3. Yep. How do you expand it when it's multiplication? Add them. So then you can split them up like this. Log 7 plus log 3 is the same thing as log 21. Kind of neat. Okay, what about the next one? Yep, so we can subtract. If we want to do that first, that's fine. So log 49 minus log 27. Okay, but here's the thing. It's asking it in terms of log 7 and log 3. So how can you write 49 as a 7? Let me see. Use exponents. 7 to what power? 7 squared. Okay. What about 27? It's not going to be 7. Obviously, you can use 3. 3 to the third. Now you're tracking with me. Okay. So, and then you can scoot these guys out in front, and then you use your log properties. So 2, 3 here. So 2 log 7 minus 3 log 3. You can rewrite logs however you want as long as you use the properties correctly.